The United States Air Force has launched one of its most ambitious defense experiments in recent years, a project named Falcon Peak, which aims to test and evaluate new methods of protecting American bases against the rising threat of small drones. Taking place at Eglin Air Force Base in Florida throughout September, Falcon Peak is being described by officials as one of the most extensive counter-unmanned aerial system trials ever conducted on U.S. soil. The initiative has drawn wide attention within the defense community not only because of its scale but also because of what it represents, a shift in how the military views drones and the risks they pose to modern security. At its heart, Falcon Peak is about replicating the challenges of defending against hostile drones in realistic scenarios. Each day during the exercise, small unmanned aerial systems are launched from Santa Rosa Island and directed toward the base to simulate attacks, reconnaissance flights, or surveillance missions. These sorties force American forces to respond using a layered system of detection, disruption, and interception tools. The 96th Test Wing, responsible for air and range safety, has placed strict controls on surrounding airspace and maritime areas, ensuring that while the experiments are highly realistic, they remain safe for both participants and the local population. The threat environment that Falcon Peak addresses is not hypothetical. Over the last decade, drones have transformed from expensive, state-owned assets into inexpensive and widely available tools. Commercial quadcopters can now be purchased off the shelf and modified for reconnaissance, targeting, or even delivering small explosive payloads. Conflicts in Ukraine, Syria, Iraq, and across Africa have demonstrated how quickly irregular forces and non-state actors can weaponize drones, often bypassing traditional defenses. These systems are small, cheap, and increasingly autonomous, making them difficult to track and neutralize with conventional air defense networks designed for larger aircraft or missiles. For the U.S. military, which operates a global network of bases, the threat is particularly acute. Facilities in the continental United States and overseas are both vulnerable to intrusion, espionage, or direct attack from drones that fly below radar coverage and can be operated remotely with minimal resources. Officials overseeing Falcon Peak have stressed that the experiment is not just about testing individual technologies in isolation but about building an integrated defense system. Radar arrays are being evaluated for their ability to detect small, low-flying objects. Radio frequency and satellite navigation jamming tools are tested for disrupting drone control links and navigation systems. Directed energy weapons, such as high-powered lasers, are examined for their potential to provide precise, rapid responses against swarms of small aircraft. Kinetic interceptors, missiles or projectiles designed to physically destroy targets, are also in play. What makes Falcon Peak unique is the attempt to combine all of these layers into a network that can share data, coordinate responses, and close engagement chains in real time. This approach mirrors the Department of Defense's broader push for joint all-domain command and control, an effort to integrate sensors, shooters, and command nodes across every service and domain of warfare. The exercise also carries a significant message about the direction of U.S. defense strategy. For years, drones were discussed primarily as tools for surveillance or as emerging threats. Today, they are considered a persistent and evolving adversary, one that requires immediate, scalable, and sustainable countermeasures. Falcon Peak reflects this evolution by focusing not on theoretical future risks but on current, tangible challenges that the U.S. military expects to face regularly. As one Air Force official put it, the goal is to ensure that bases can defend themselves in the modern era, when cheap and accessible aerial systems have become widespread. The implications of Falcon Peak extend far beyond Florida. The Joint Counter-Small Unmanned Aircraft Systems Office is expected to use data from the experiment to inform acquisition strategies, guiding the military on which technologies to prioritize and procure. The exercise will also influence the development of new tactics, techniques, and procedures for Air Force security forces and potentially other branches of the military. In practice, this could mean rewriting doctrine for base defense, training new units, and incorporating counter-drone strategies into joint operations across Europe, the Indo-Pacific, and the Middle East. By shaping both procurement and doctrine, Falcon Peak has the potential to define how the U.S. responds to drone threats for the next decade. The choice of Eglin Air Force Base as the site for Falcon Peak is no coincidence. Eglin offers extensive test ranges, proximity to Gulf airspace, and the infrastructure needed to conduct large, complex exercises safely. The 96th Test Wing, headquartered there, has long been involved in pushing the limits of military technology, and its role in Falcon Peak highlights the importance of Florida's Gulf Coast as a hub for experimentation. The participation of contractors, research agencies, and joint service teams underscores the collaborative nature of the initiative. While specific platforms remain classified, the involvement of industry partners ensures that the lessons learned will directly influence the next generation of defense products entering the field. From a broader perspective, Falcon Peak also illustrates how the United States is adapting to asymmetric threats. While traditional military power still depends on advanced aircraft, ships, and armored vehicles, small drones have shifted the balance by offering adversaries cheap and effective ways to bypass conventional defenses. The experiment is a recognition that modern battlefields are no longer defined solely by large-scale confrontations but also by swarms of small, inexpensive systems that can achieve strategic effects. By preparing for this reality, the U.S. Air Force is signaling that it intends to stay ahead of the curve and ensure its bases remain secure under evolving conditions. As the exercise continues, analysts are watching closely to see which technologies prove most effective and how the Air Force adapts its tactics. Directed energy weapons, in particular, are of interest because they offer the potential for virtually unlimited ammunition and instantaneous responses, though they remain limited by weather conditions and power requirements. Similarly, electronic warfare tools could offer broad protection but risk interference with friendly systems. Kinetic interceptors provide reliability but can be expensive if deployed against very cheap drones. Balancing these options in a cost-effective and operationally effective way is one of the central challenges that Falcon Peak is designed to address. In the end, Falcon Peak is not simply a test of machines but of strategy, doctrine, and adaptability. By simulating hostile incursions and evaluating layered defenses, the U.S. Air Force is building the foundation for how it will counter drone threats at home and abroad. The lessons learned will not only inform technical acquisitions but also shape the mindset of American defense planners as they consider the role of drones in future conflicts. With drones already proving decisive on battlefields around the world, the results of Falcon Peak could very well determine how the U.S. military safeguards its installations and maintains its technological edge in the years to come.